My name is Jess Holbrook. I lead the People Plus AI research group at Google, and my talk is about human-centered design, how we've gotten to where we are, the assumptions that underpin the theory, and how some of those may be shifting and how we might adapt the way that we build products in the future. So I want to start with a little story about what a lot of people would view as a success of human-centered design, the humble water bottle. So if we think about human-centered design along the axes of useful, usable, and desirable, a water bottle really fulfills all of those. It's useful. It's quite useful to be able to take water with you wherever you go, especially in places where it's not easily accessible. It's usable. You can turn the cap, you can get water, you can put it in a purse, you can put it in your hand. There are accessibility challenges there, but for a lot of people, it is quite a usable product. And it's quite desirable. So there are nice logos tempting you to drink the beautiful mountain spring water, and drinking cold water is very refreshing and a beautiful little dopamine hit. But on the other end of things is a lot of these bottles, depending on what they're made of, will be with us for around 400 years. They'll be filling landfills in oceans around the world, and they'll be primarily doing this in places that did not create this kind of never-ending stream of plastic bottles out of production. So what's happening here? What went wrong? Why do we see something that, in theory, met a lot of the criteria of human-centered design, but is yet has all these negative consequences? Well, I think there's a couple reasons for that. I think one is a narrowing of focus to just a product and not the system around the product. I think the second is that the creation of these water bottles and the business model around them really ignored a lot of other relevant scientific and social fields of inquiry. And the third is that the thinking was very short term and didn't appreciate the fact of how quickly the production of this thing would escape human scale. And so if we are starting from the wrong assumptions or assumptions that aren't as relevant as they once were, we're going to keep making these kind of mistakes. So it seems like it's time to start evolving the assumptions that underpin human-centered design and the making of things if we want to do better in the future. And I want to talk about three ways that we might do that. The first one is that we need to recognize that we are now building systems, not things. Human-centered design really began an aim to make systems usable and useful by focusing on users and their needs and requirements. I think it's important to go back and look at a bit of the evolution of human-centered design to understand how we got to where we are and how our focus has narrowed. I mentioned this earlier. This is a little different version from useful, useful, desirable, viable, feasible, desirable. But this is the way that we tend to conceptualize all of our products. It really started in the very beginning of human-centered design, where before human-centered design you had HIPPOs. So for people who aren't familiar with this acronym, this stands for the highest paid person's opinion. This is how decisions are made in most organizations still to this day. On our little jungle journey here, from hippos we evolved to bees. So this is referencing Mike Cooley coined the term human-centered systems in his book Architecture Bee, really trying to reframe some of the technical innovation at the time in the 1980s toward a more human-centered approach. From bees, we really moved towards the codification of these principles. And so this, at least for me, was really done by Don Norman, taking these ideas mainstream through the psychology of everyday things, later named the design of everyday things. For me personally, this is what got me into the field of user experience and human-centered design. It really just was a revelation when I first read it. And from there, a lot of these concepts were scaled throughout the industry and through different sectors. So IDEO, Stanford D School, CMU, all these places really took these ideas and put them into the mainstream. And because of this, there were a number of wins. There was a lot of success that has come from this. So just to highlight a few, one of them is that human-centered design really shifted our mindset from being fascinated with things to being fascinated with people. Really before, there was this kind of almost complete focus on the product or the thing and not really getting to know people if you were outside something like a sales organization or something like that. The second is that human-centered design exposed the concepts of design thinking and empathy to the mainstream of product development. I mean, these were quite foreign, right? It was almost an adversarial approach to product design and sales before this kind of philosophy of empathizing and getting to know and becoming proximate to your users or your customers. And then third is really, it was a big part of returning a lot of humanity to product development after we'd been through decades of mass production, pulling us away from any craft or delight or joy in designs into pure functionality. So the place where we want to really start here is that human-centered design has really served as the essential guiding force for product development over the past, let's say, 30, 40 years, depending on how you count it. It has delivered an amazing amount of good, from consumer products to business applications to nonprofits, government agencies. It has shifted countless people away from a technocentricity to really thinking about the technology, the business case, and the people involved. It has helped prevent numerous doomed to fail product market fit misunderstandings, wastes of private and public money. But at the same time, it has resulted in some pretty big misses or conditions that we now find ourselves in. So one of those is that human-centered design is always aimed to make tasks easier. This is just a fundamental part of it to complete, but never really considered the downsides of frictionless interactions. We hear this all the time: make it seamless, make it frictionless, make it so easy to do. But there's a consequence to this. And so whenever you do that, you are abstracting away some part of the process, right? The more and more frictionless you make something, the more and more of the mechanisms or the system that actually exists, you're hiding. This is called abstraction, or in actor network theory, they talk about punctualization. And so the canonical example here is if you buy something on the internet. So you click a buy button, and the next thing you know, you get a little thank you receipt and something shows up at your door. But the click of that button sets off a massive wave of action, from code to humans moving things around in warehouses, to packaging, to cars and delivery trucks on the road, to organizing their routes, to the delivery drivers, to their working conditions, to everything about them, parking on the road and maybe blocking traffic behind them to get you that package. And so we're seeing a larger and larger detachment from the consequences of our actions, as human-centered design has really pushed for this unrelenting assault on friction or seams of any kind. We're also seeing a challenge of, human-centered design made many things very beautiful, or more beautiful than they were before, but aesthetics can be deceiving and skew judgments of value. We kind of all know this. Like, you can think of here as people can be caught trading short-term aesthetics or small feelings of accomplishment for longer-term consequences. And one of these might be something like location sharing, where you get a badge, or you get some kind of gamification of a service, where you're trying to kind of get these the highest score on the scoreboard or a badge or something like that, but really giving up information like your location, that you may not know how long it's stored or what it's used for or anything else like that. So we have this trade-off that's happening there as well. And then the third is that human-centered design made sharing among people easier, but it really costs nothing to share destructive ideas or to instigate conflict. I don't really think I need to go in depth here. I think people are pretty familiar with this at this time, but this is again a reminder that seams aren't bad, friction isn't bad. Enabling everybody to do anything they want at any time is not consequence-free. And it's interesting to see a lot of the platforms are actually starting to are starting to reinstitute seams, friction, pauses in their experience to try to build in and design for contemplation, and a little slowing down of what's been where they've been trending for so many years. So if we have these, we have this core that has served us very well for decades, right? But we're starting to see the misses and the consequences of that. You have to remember a lot of these core ideas are decades old, and they arose before there was the large online platforms, before there was machine learning and AI, before there were a lot of these exponential technologies. And so it feels like there's a time for an expansion of these. And that's something that we've been trying to work on in our group at Google for a while now. So the area that I focus in is in machine learning and artificial intelligence. And so one of the ways that we tried to approach this is taking the human-centered design philosophy and bringing it to AI, human-centered design for AI, or human-centered AI, whatever you want to call it. And through there, we've been trying to do that through different efforts at different levels. So one is things like our AI principles that really lay out what we will and will not work on. Another are teams and organizations. So this is how we do this through our People plus AI research team. And then we try to create these resources that enable user experience folks, human-centered design practitioners, builders of anything, build AI and AI-powered experiences in a more human-centered way. And these are things like the People plus AI guidebook. We've been doing this for years, and we still don't think it's enough, though. We still think that there's a miss. And part of that is really about how you orient to the work in the first place. And this comes back to the point about systems, not things. So all of those things will still just get you better things, but not a better system. One of the people we're really inspired by is Professor Andy Clark, who, if you're not familiar, has written for a number of years about things like the extended mind and things about how to think about humans in relation to their world, especially how the mind manifests in the world. One of the things he's been talking about for quite a while is a new, we're in a stage now, we're in a new human data ecology resulting in these systems of systems building on top of each other. So we will, one of the things his work is really famous for is something called the extended mind, where it thinks about how we extend our mind into the world. And the canonical example is when we take a pen and paper and write something down to read it later. That's an extension of memory that we've done. So now we're in this place where we are extending ourselves into the world, but we're doing so through these interconnected platforms driven by machine learning and AI that are extending us further and further into the world more permanently and connecting to more people more programmatically. And because of that, we're also now able to, frankly, affect each other across the world more dramatically than we ever have previously. And we need to start thinking about this from a systems point of view versus a feature or a product point of view, because that's not the appropriate unit of analysis. It doesn't matter about one particular platform or one particular feature. It's the fact that they're all interconnected and feeding into each other and connecting people and extending minds into the world in ways that we haven't seen before. Another person that we're very huge fans of is Donella Meadows. So she's one of the foremost systems thinkers. And one of the ways you can kind of think about a system is how you can move it and the different levers you have to change a system. So I'm not going to go over all of these, but one way you can think about it is you can have things you can change that are close to the fulcrum that aren't really going to move the system all that well, and things that are far away from the fulcrum in this diagram that will change. What a lot of people are doing is focusing on things that are close to the fulcrum. So these are things like changing the metrics we use to measure a system or the performance of something, changing features, maybe adjusting the flow through an app's experience or something like that. But really we want to be toward the other end, away from the fulcrum, where we're looking at the rules of the system, how the system self-organizes, the overall goal of the system itself, what is the point of it, and then all the way up to paradigms that the system is used in and the ability to shift the paradigm that the system is in. And I think one thing to take a pause here is to maybe think about, if you are a designer or a user experience professional or just somebody who builds and makes things, where do you spend most of your time? Is it close to the fulcrum on the small things that will not change the system, or will not really affect the system in which whatever you're building lives? Or are you spending more of your time away from the fulcrum, really thinking about the goals of the system, how it self-organizes, the rules that you're putting in place to help it do so, or even the paradigm in which it exists? So thinking in systems versus thinking about things is one big first step. But another is to start thinking more laterally, not just linearly. Human-centered design has really got us into this linear mindset where we're kind of thinking about one user's experience through time, through a particular app or feature or whatever it might be. And we become very rigid and systemized in a lot of thinking. This is kind of the rise of design systems that we've seen over the last decade or so, which is really trying to kind of create these almost very specific funnels predicated on predictability, which is a good thing, but moving people through a very particular experience, and then you're starting to see this kind of like homogenization of experiences across products in the web for sure. So I'm a social psychologist, and so I think a big important thing here is to realize that nothing really exists in a vacuum. Nothing really has meaning outside of its relationships. This is a big concept in actor network theory, and it's hard to actually even think about what certain things are without thinking about them in relation to everything else. I apologize for trotting out the philosopher in my talk, but Heidegger brings this up and talks about this a lot. Around 1950 or so about 70 years ago, he would refer to something called referential totality, thinking about things like there are tools, but tools only have meaning in relation to something else. And one of the classic examples is you talk about usually the meaning of a hammer is that it lets us drive nails. It's hard to understand a hammer or a nail without understanding. It's hard to understand one without understanding the other. It requires you. A hammer requires you to understand nails and wood and how it grips nails in trees, and that there's an economic system that turns trees into lumber, forest, and the human need for shelter. This is all embedded within itself, and it's all connected. And so one way we can kind of think about that as well is that kind of connectedness can be a way for you as a product developer or a product designer or a product maker to start to think outside of the really linear and narrow view and start to think about what things are connected to and have that inspire you. So another thing here, to bring it to a much more recent example, is in 2015, some researchers at Google asked a deep learning system to come up with what it thought a dumbbell is. I apologize for using the anthropomorphic language here. It's really hard to get away from that. The AI models do not think, they don't see, but it's just really hard to not speak in very jargony terms without using that. And so they said, okay, how is the model representing a dumbbell? If we plug that into the Google search bar, it's a pretty straightforward answer, right? Like you'd probably literally get the definition, a short bar with a weight at each end, usually used typically in pairs for exercise or muscle building, probably with a figure or something like that. But what the AI researchers found was this. It's kind of a blurry image, so I'll kind of talk through it. There are dumbbells in there, but what you kind of see are almost like two arms joined at the elbow, each holding a dumbbell. And when the researchers looked at this, they thought it was a data problem. So they thought that the examples that were used to train the AI model did not include enough examples of just a dumbbell sitting on its own. And they said, this is an error with the model. This is a problem here. And it failed to completely distill the essence of the dumbbell. But there's another interpretation there, which is how do you even think about a dumbbell without thinking about somebody using it, without somebody holding it, without somebody trying to get stronger with it? And it's this really kind of amazing visualization where we can start to see a visualization of the statistical relationship that the model is finding to help us start to think about different ways to conceptualize dumbbells in the context of use. And this really just challenges us. Again, what is the meaning of a dumbbell outside of its use? The example I just showed you was from a computer vision model trying to learn about images and create images. Or recognize images. This is another example from a language model. What we're looking at right now is called an embedding space. So what it's trying to do is really represent in a relatively low dimensional space, high dimensional vectors, which is a way that the machine learning and AI models represent concepts. And so in here you can see dumbbell in the foreground. And we can use things like embedding spaces to actually try to think more laterally about our problems, try to understand the statistical relationships that models are finding. In this way, machine learning and AI models can almost be like co-discovery partners as we're trying to think more laterally about concepts and find new relationships and get inspired in different ways. So this really brings us to this idea that's kind of central in lateral thinking, which is, we have the dumbbell and then we call it the deep bell, but it's really this marriage of discovery and invention. So you have, and I really love this term discovery and invention because it really pairs the two activities that we almost all partake in. Discovery is really about learning about the world, and that can be from talking to users, understanding user needs, reading scientific papers, anything like that. And then invention is through the making, right? It's through the creating something that nobody really asked for, but is a useful tool to learn about things. And so you can get into this really nice, beautiful feedback loop with that, where you have, inventing something teaches you something. You learn by making. And then that can be paired with a greater discovery, which then can inspire a next invention, and you get into this fruitful feedback loop. Another really interesting thing that we can do to help ourselves think more laterally is to start to learn from other fields or other areas where we don't normally do that. And one of the best examples of that is something called sleeping beauties. So sleeping beauties are research papers in science. There are these research papers that basically go unnoticed for a long time. So they come out, they're cited a few times, and they go unnoticed, usually for decades. And almost suddenly they attract a lot of attention. You know, they are awakened or kissed by a prince or whatever you want to call it. And so one of the ways that this happens is that, it is discovered by another field. So they have a great thing called the beauty coefficient, looking at how active, how basically sleepy the beauty was, and how quickly it was woken up. And so you have like an example here about the citations per year, and then all of a sudden you see that spike up at the end. And one of the ways that they usually spike is because another field finds them. So this is what's so fascinating, is that you have these papers that may have been very relevant to another field and accelerated it on a much earlier timeline if they had known about it. So one is, a couple examples here. The first is quantifying beauty. So this was, looking at a paper by Einstein, actually, that was really looking at quantifying beauty. Quantum mechanics was asleep for about 60 years before it kind of got picked back up. This is one of the big examples that people trot out. Another is probably not all that surprisingly, especially anyone with some statistics background that might be watching this, is a Pearson paper from 1901 that slept for 100 years and then become very relevant in the machine learning and AI fields, which of course are highly dependent on statistical relationships to get models to work. And then the third one here is one of my favorites, and it's an example there where there's transfer from anthropology to online network theory. And so this is a way to look at fission in groups, and it took examples from anthropological research of people in the real world, and then was able to have a theory about how they would groups would come together in online social networks as well. So this is one of these pieces of discovery and invention that the Sleeping Beauties really represent, is this thing that we ask ourselves on our team a lot, which is just first, when you're facing a really challenging problem, it's just, who has solved this well? Who's already solved your problem? Maybe in a different field. Maybe they call things a little bit different names than you. Maybe there's, not as tight of a correlation to your problem as you'd like to see. But if you can open yourself up to seeing your problem in a different light and in a different framing in a different field, you might be able to solve it. Another thing that we do is, just embrace the fact that every idea comes from a previous idea, or at the very least, it comes from some kind of a change applied or formula applied to a previous idea. One of the ways that we think about this is Ramesh Reskar's idea hexagon. So you can take an idea, and then you can really look at all the different ways you can try to change it and think laterally about it to find some kind of new discovery or new invention. So if we go back to our dumbbell example from before, we look at these 6 different ways that you can try to change this idea and learn something new about it. Mutation, evolution, synthesis, destruction, recombination, alchemization. I'm not going to go over all of these, but you can have some kind of synthesis where we can take our dumbbell idea and our water ball idea and say, what happens if we combine these? Do you all of a sudden have a dumbbell that has water in each end that you can refresh yourself during the workout, get lighter as you're getting more fatigued, something like that. And then something that's really interesting and near and dear to my heart is this alchemization ability. With the example that we went over before, is you can take a concept and you can use a machine learning model almost as a diagnostic tool, or a tool to learn more about that concept than you could with anything else. And from there, you might find a new kind of way to combine concepts that the machine learning model is finding a statistical relationship between that might inspire more of your work. But at this point, I've been talking about discovery and invention for a while, and I know that there's at least some people in the crowd that are kind of getting this feeling of that they've heard this before, about the Henry Ford quote of like, okay, great, all I got to do is invent, and people don't know what they want and all this kind of stuff. It's the classic quote of, if I'd asked people what they wanted, they would have said faster horses. And this is an important point for me, that I'm very much not endorsing this in any way. I hope everyone out there knows that there's no evidence that Henry Ford ever said this. None that I've ever been able to find in any way. And it matters a lot because a lot of people use this as an excuse for hubris, as an excuse to do whatever they want, regardless of how it affects people or what people tell them. And so, I think that this is the exact wrong way to go when we talk about discovery and invention. And instead, there's this other Henry Ford quote that I really love, and it says, if there's any one secret of success, it lies in the ability to get the other person's point of view and see things from that person's angle as well as from your own. And this is this beautiful marriage of discovery, empathy, and invention. So if you ever hear somebody say the faster horses quote, I encourage you to try to get them to replace it with this one. With that, we'll move on to the third element, I think, of the expansion of the kind of assumptions that we need to ways we need to expand human-centered design. So we've been talking about systems, building systems, not things, ways to think laterally, not just linearly. And now I really want to talk about the marriage of fact and fiction and how we can bring these together. So one way to think about this as well is everything we've been talking about so far has been about the past and the present, but how do we start to think about the future? And a lot of times the way that we think about the future is through a brainstorm. At Google, we use a lot of how might we's. And we've all been in a lot of these. I'm sure a lot of people watching this have been in these situations. Some are useful, but a lot aren't. And I'd like to throw out a couple reasons why they aren't. And they really relate to the last two points we were making. One is because brainstorm blue sky ideas oftentimes are about a thing, not a system. They're intentionally very narrow, and they're not really going to produce the effect you want. And then also they're sometimes lateral. If you're doing it right, you're kind of riffing off ideas, but it's still really contained within whatever the context of the brainstorm is. And so you're never really going to get that really, you kind of have the illusion of a diversity of thought, but you're never really actually going to get there. And so, and you're not going to actually work through a lot of the hard problems there. And so on our team, we try to work on something that I like to call like pocket futures, which is a way to try to represent a system, and hopefully inspired by lateral thinking, that is small but complete. So it is along a narrow path, but it allows us to really live in one potential future we might hit. And if this sounds familiar to you, it's because it really is inspired by speculative design. A lot of people watching this will be familiar with it, but for those who aren't, speculative design is a way to think about possible futures. So if you have the present here and time is moving from left to right, we go out into many different kinds of future. Going away from the center of the cone, you get into futures that are less likely, and in the middle is probably the most likely future that we're headed towards. But what speculative design does is really formalize and have people think about which of these are the preferred futures we'd like to go to. And there's many ways to try to experience those preferred futures, those little pocket futures, as we mentioned. So one of the most mainstream examples of that is the show on Netflix, Black Mirror. For those who aren't familiar with it, it's a show that really takes a look at a particular technology or technological advance and extrapolates it out to a whole kind of world building, usually with a dystopian flair to it of everything went wrong and we did a lot of things really bad. These are really interesting. They're very entertaining. They're very telling. And there's actually something I think a lot of teams could learn from those, which is more companies having what are called red teams in security the security disciplines. So that is when you have a group of in most technology companies, you have a security team whose job it is to try to attack the technology company's defenses or perimeters in a way to basically harden their own security. We could do a lot more of that in user experience design, product building, in the way that we could build teams to really try to look at the things we're building and look at them through a lens of focusing on harms, of focusing on potential problems, and not shying away from that. Most of us do not have the budget to create Black Mirror episodes, but luckily there's some other stuff we can do. There's all these different kinds of ways, coming back to AI and machine learning, that we can do, that we can simulate intelligence both in the early stages and later stages. And two people from our team, Mike Dory and Mindy Deli Carpini, wrote a really great blog article recently on this. So we can do early stage prototyping, really just using wireframes, Wizard of Oz techniques, trying to assess, like, should we do this thing in the first place? Can we, should we even pursue this, or do we actually find big usability issues, big usefulness issues, big potential harms that would make us want to stop in the beginning? And then later, we can actually do some prototyping with data. So there are a lot of technologies already that allow you to build and create very small machine learning models to start to experience some of these simulated intelligence experiences very early on in the process, and then also kind of trying to understand, well, like, can we do this? Could we get it to work well enough? And so a canonical example of that is a really great experience called Teachable Machine. So if you want to experience this for yourself, if you just do a web search for Teachable Machine, this will come up. This is an experience that allows you to train a computer vision machine learning model in your browser using your webcam in about, 30 seconds, something like that, very, very quickly. There's lots more variants now, but that was kind of the original one. And this is built on top of a technology called TensorFlow.js, which came out of the Pair team. And so how it works is you can hold something up in front of the webcam to give it examples of one class of things. So here, they're just doing like a banana ripeness recognizer. So here is an example of, this is what a ripe banana looks like. It's giving the model a bunch of examples. Then you say, okay, here's what a too late or a too ripe banana looks like. Again, giving the model lots of examples to learn these things. And now you have a model that can recognize both. So as you see down below there, you have basically the model saying how confident it is that what it's seeing is either too early, ripe, too late, or there's not a banana in the frame. Again, apologize for using anthropomorphic language, but it's very hard not to do. And one of the really great things is this allows a couple things. So it allows you to speculate into the future. So it allows you to build models that don't exist yet, at least in a little prototypey way. It allows you to feel them, frankly, like not just intellectualize them, but to feel like, okay, what would it be like if there was a recognition of this kind? This is a kind of a silly banana example, but you can think of lots of others. And then start to understand and understand the consequences. As you start to prototype more and more, you don't have to rely on having this otherworldly imagination that allows you to think of every possible variable. And so it allows you to start to think through some of the consequences of some of these decisions in more detail. And then they're also, of course, just perfectly tailored to what you need. So we've looked at, thinking in systems, not things, lateral thinking, not just linear, and trying to marry fact and fiction. We have this amazing core from human-centered design. It's served us well, but it's starting to result in problems that aren't going to get fixed with the same assumptions. So I think it's ready. I think we're ready to expand that, to really start to focus, to assume from the beginning that we are building systems, not things, to assume that the right answer is probably looking laterally, not linearly, and both understanding how things don't just relate to themselves in the past and future, but to other things in space and time. And third, to really start to marry fact and fiction together so we can have a firm understanding of the past and present and have a purposeful imagining of the future. And with that, I will say thank you for being here. And if you'd like to get in touch, here's my information on the website. And I'd also really like to thank Alex David Norton, who helped me make this presentation. Thank you very much.